Hello, math fans, I've missed you. This is Mrs. Simonet. You're here for Math Intervention. Your goal today is to find the greatest common factor, or GCF, of given numbers using a strategy that's different from the ones your math teacher has taught you this week in your regular online math class. Today you'll need a pencil, a piece of paper, or you could print off the note sheet from Google Classroom. You'll also need a prime factorization chart. You can either look at it digitally from Google Classroom, so on your computer screen, or you can print it off if you have access to a printer at home. When I say the word factor, it's defined as numbers that can be multiplied together to get a product. Please know that every number has a factor of 1. In fact, 1 times 12 is 12, so both 1 and 12 are factors of 12. I can see on my multiplication chart how 1 times 12 is 12. Looking across the next number for a 12, I'm looking across the 2, I find 12 and look straight up, and I can see that 2 times 6 are also factors of 12. I can multiply those numbers together to equal 12. Looking across my next number 3, I find the 12 and look straight up and see that 3 times 4 is also 12. So they're both factors of 12. When I look at my multiplication chart across the 3, I can see that 4 times 3 is 12. But then I notice something. I already have used the factors 4 and 3 with 3 times 4 because multiplication is commutative. And so that's how I know I can stop looking for factors of 12, because I've run into factors that are repeated. So that's my list. I'm done with factors of 12. Your math teacher taught you how to list them in order from lowest to highest. Now, is it really important that you make that list that way? No. Is it important that you know factors of 12 and can find them? Absolutely. Looking at greatest common factor now. It means that you're looking for the greatest number on your list of factors. It's defined as the greatest number that is a factor of more than one number. The abbreviation for greatest common factor is GCF. So you're looking for, again, the greatest number that is the same on both of your lists. Looking at examples of this right now. When I look for factors of 18 on your multiplication chart, I know that 1 times 18 is equal to 18. Then I can look across the 2 and see, is there an 18? Yes. And look straight up to see that 2 times 9 is also 18. I look across the row for 3 to find 18, and there I see it. 3 times 6 is also 18. When I look across the 4 for 18, I don't see one, so I know that 4 is not a factor of 18. And doing that same strategy with 5s, I see that 5 is not a factor of 18. When I look at 6, I can find 18, and looking straight up, I can see that 6 times 3 is 18. However, I have already used the 3 and the 6 in my list, and so that's how I know I have found them all. You look for factors until you've repeated them. On your multiplication chart, doing 24 now. 1 times any number gives me that same product, and so 1 and 24 are factors of 24. Looking at my multiplication now for 24, I can see, looking across the 2's, I see 24, and looking straight up, 2 times 12 is equal to 24. Looking at now straight across the 3's, I see 24, and looking straight up, 3 times 8 is 24. And so what happens when you have a list that looks like mine and you get to the next number 4 and look straight across and see 24 with 6? 4 and 6 are also factors of 24. Now, is it okay to add them at the end like I'm doing right now? Absolutely. And so that's my list of factors of 24. When I look for the GCF, I'm looking for the greatest number that's on both lists, and then I circle it. And so when I'm looking, I can see that 1 is on both lists, but so is 2, and so is 3, and so is 6. And 9, though, isn't, and neither is 18. So the greatest common factor is the greatest number that's the same on both of my lists, which means the greatest common factor of 18 and 24 is 6. It's the greatest common number. Looking at now, if you don't have a multiplication chart or don't know all of your multiplication facts, at another way to find the GCF, we're going to use prime factorization to find it. Now, is this why your math teachers taught you how to do prime factorization already? Of course, because they knew that that is one way of finding common factors of numbers. Now, last week, you learned how to make factor trees to find the prime factorization. Please, on your paper, make factor trees for the prime factorization of 18 and 24. Your trees will start off for 18 with 2 times 9. And then for 24, please use 4 times 6 to start your factor trees. After you're done, I need you to answer a question that's on your Google form today before you move on to the next video.